Welcome back to my channel. This is Chimoli Arnold. Yes, sir. I happened to delay with my model. Now, this is a presentation of my EDA, Exploratory, Design Analysis. So I happened to delay a bit. My notebook had been giving me some hard time, and I happened to talk to you about it. So allow me to proceed. So here I was able to play the audio file. And just a small reminder that my model is a scream detector. I made it in order to help out in the community, in that there are cases where the police is unable to reach out in time to solve that problem or the crime. This is more visible in the nights where there are many robberies and stuff like that. So allow me to proceed. Heat maps. A heat map is a data visualization technique that uses color coding to represent values of two-dimensional matrix. Now, in this case, a heat map would be very important to help us classify our audio files and different sounds. Our correlation matrices is simply a table which displays correlation coefficients of different variables. It consists of rows, columns, and shows the variables. Each cell in a table contains a correlation coefficient. Same thing, correlation matrices are also used in the same way. Just to move on, I was also able to display a waveform of the screen that we sampled. Though I was unable to draw different graphs due to certain reasons, let's say lack of data. For example, if you were to construct heat maps, if you were to construct correlation matrices, you're supposed to have numerical data. In this case, I had only audio files which had no numerical data. Yes. Incompatible data format. Even if you do have two-dimensional data, it's possible that the format of the data is not compatible with the heat mapping software or tools. In this case, you may need to convert the data into a format that can be used to create a heat map. Yes, allow me to move on. I was able to test and validate my data. In that, I got a test loss of 0.69 and a test accuracy of 0.52. It was so sad that my model isn't as accurate as I expected it to be, due to some issues. Then down here, I show you how I was able to upload my data set to Cargo. So you can always find it there through that link, and same thing to my notebook. Yeah, just to move on. We have box plots, also called whisker plots, created to display the summary of the set of data values having properties like minimum, first quartile, median, third quartile, same thing. It shows the frame clearly using the transparent small circles. I wasn't able to represent all of this due to lack of numerical data. Now we have feature independence plots. In the data frame, these plots show how different features vary with other features. Feature independence plots, FIPs, are a type of data visualization that can help you understand the relationship between two features in a data set. Here's a general process of creating FIPs. Firstly, choose two features. Select the two features you want to explore and make sure they are numerical or can be transformed into numerical data. But we find that since we are dealing with audio files, I was unable to develop them. Yes, just to move on. Outlier plots, same thing. Outlier is an extremely high or extremely low data point relative to the nearest data point and the rest of the neighboring coexisting values in a data graph. An outlier is an observation that is numerically distant from the rest of the data. Same thing, I was unable to represent this, but we're moving on. Confusion matrix, at least is almost the same as a heat map. It's also used at some point in classification, helps us in classification. It's a table that compares predicted and actual labels of a classification model. It column of the matrix represents the instances in a predicted class, while each row represents the instances in an actual class. And the diagonal elements of the matrix represent the number of correctly classified instances. All right. So if you are using chroma features, I was able to illustrate different patterns. These visualizations can show how well the model is performing in terms of correctly identifying different sound classes or events. Using chroma features are a type of a feature used in musical analysis that capture the harmonic content of an audio signal. Chroma features are often used in tasks such as genre classification, chord recognition, and melody extraction. Basically, chroma features could show different patterns of interest. Well, I was also able to construct or develop a spectrogram. A spectrogram is it helped me illustrate, different patterns over time and space. A spectrogram is a visual representation of the spectrum of frequencies of a signal as it varies with time. In other words, it shows how the frequency content of a signal changes over time. In audio signal processing, a spectrogram is often used to analyze the frequency content of an audio signal over time. It can be used to identify specific features of a sound, such as harmonics, overtones, and other spectral components. Yeah, thank you. On making further research, I learned that I could create numerical data given audio file. Well, I tried importing the CSV file, but then I was kind of defeated at some point. So I realized it was possible to create numerical data out of given audio files, where you had to tokenize the data, But yeah, exploring and cleaning data, I was able to do this. Data exploration is the first step in data analysis and typically involves summarizing the main characteristics of the data set, including its size, accuracy, initial patterns in the data, and other attributes. Data cleaning is the process of preparing data for analysis by weeding out information that is relevant or incorrect. This is generally data that can have negative impact on the model. And for example, for my audio files, I got my data set. It had MP3 files, it had WAV files, so basically I explored, I managed to clean my data properly. And yes, I removed the duplicates. So splitting data into train, validation, and test sets. Train, tuning, and model selection and testing are performed with 3 different data sets: the training set, validation set, and testing set. Validation sets are used to select and tune the final AI model. Training sets make up the majority of the total data, averaging 60%. In testing, the model are fit to parameters in a process that is known as adjusting weights. While a validation set is a set of data used to train artificial intelligence with the goal of finding and optimizing the best model to solve a given problem. Validation sets are also known as dev sets just in case. When we come to tuning hyperparameters, the process of searching for an ideal model architecture is referred to as hyperparameter tuning. This is done to control the behavior of the model. A machine learning model is defined as a mathematical model with a number of parameters that need to be learned from the data. By training a model with existing data, we are able to fit the model parameters. However, there is another kind of parameter known as hyperparameters that cannot be directly learned from the regular training process. They are usually fixed before the actual training process begins. These parameters express important properties of the model as its complexity or how fast it should learn. Well, coming to my last slide, fitting any initial model and evaluation and dataset. Here we will adjust the parameters of the model in order to improve its accuracy. We run a machine learning algorithm on data for which the target variable is known. Then the model's results are compared with the real observed values of the data variable, of the target variable. Yes, then when we come to evaluation of the data set, the train, test, and validation sets of the data set are given for easy training, testing, and validation of the data. We further find the accuracy, precision, recall, and F1 score of the model to measure the model's performance. Well, thank you for your time. Thank you for your time. Thank you for listening out to my EDA video, and I can't wait to see you on my next one. I'll be presenting my term paper of the whole model. It's been a long journey. Thank you.